Howdy. I'm really glad you guys could all come. It's Thursday at noon, and it's been a really long week. I'm really glad I had an opportunity to meet a bunch of you guys and ask the experts last night, and I'm really glad that you guys showed up so I can talk about the changes we're building in the audio system for Windows 7 to enable a whole new class of experiences for audio applications. My name's Larry Osterman. I'm a developer at Microsoft. I've been there for a fair while. And as I said, I work on the audio team. So about 2 months ago, a month ago, my wife finally managed to convince me that it was time to upgrade our 27-inch TV to some high-def TV, flat screen, whatchamacallit. And I got to say, I love the system. It's wonderful. You know, I got the big 1080i satellite images and all that stuff, and it's great. There's one thing that bugs the heck out of me while I'm watching TV, though. I'm sitting here watching TV, and somebody calls me on the phone. And all of a sudden, I got to get up out of my chair, and I got to go running around, not trying to find the phone, but trying to find the remote for the TV so I can pause my TV, so I can turn down the volume, so I don't miss my TV while I'm taking the phone call. And that bugs the heck out of me. And wouldn't it be great if we had the ability to have your phone integrated into your media PC and have your media PC stop your live TV while you take that phone call and start it right back up when you're done? Well, in Windows 7, we're laying the foundations that let that experience happen. We're setting the groundwork for you to be able to get that kind of experience in your day-to-day use of audio in Windows. So what I'm going to be covering is the new audio features in Windows, an overview of Windows Vista Audio, then I'm going to go dig deep into some of the Windows 7 features, the new audio features in Windows 7. Afterwards, I'll have a demo of some of the features, and I'll show how you can enhance your applications to take advantage of these new features. And then at the very end, we'll have some time for Q&A when we're done. So, how many of you guys have one of these? It's a Bluetooth headset. Similarly, how many of you guys use Skype or Vonage or one of the voice-over IP services? Yeah, I see a whole bunch of people. How many of you guys use multimedia instant messaging? You know, chat using your Yahoo AIM or Live Meeting or whatever. How many of you use Live Meeting? How about WebEx? How about GoToMeeting? Yeah, there's a lot of you. And that's consistent with the research that we've been doing. But while we were starting the planning for Windows 7, we actually went out and did a lot of market research about the state of how people were using their PCs with respect to multimedia. And one of the things that came out, there's a couple data points we found that were really quite extraordinary. One of them was related to Bluetooth. In 2005, there were like 35 million Bluetooth headsets sold. The expectation is that in 2009, there will be 120 million Bluetooth devices on the market. Those are crazy numbers. In 2005, there were 35 million laptops sold with Bluetooth. Today, 20% of all PCs sold have Bluetooth capabilities built into the machine. There are hundreds of millions of customers in multimedia instant messaging who use multimedia instant messaging. In fact, our numbers show that on any given week, there are 100 million PC-to-PC multimedia communications happening. That's 100 million customers every week are using their PCs to talk to each other, to using webcams, to conference, whatever it is. 100 million people. That's a lot of people. So it's very clear that communications is clearly the way that the industry is moving, that our customers are moving, that people who want to use these machines are using it. They want to use these machines to communicate. So for Windows 7, we sat there and said, well, what can we do to focus and to make it so that Windows 7 allows these users and the software developers who are building on top of Windows 7. How do we make sure that we have the best experiences for multimedia instant messaging, for VoIP applications, live meeting and other meeting conferencing solutions, et cetera, et cetera, et cetera. So for Windows 7, we're really targeting that set of features. So what did we change in Windows 7? The first thing we did is what we call improved device role detection. And the idea behind this feature is that we want to set things up so that when you're a multimedia application, if you're Skype and you want to use audio, well, it would be really nice to be able to have Skype talk to the user's Bluetooth headset and to know which device the user has chosen to use for their headset, so that Skype doesn't use your PC speakers by default, or you don't have to do magic configuration in Skype. The system itself is smart enough to know that, oh, that's a headset that just got paired with the system. They're probably going to want to use that for voice chat. But you know what? They're probably not going to want to listen to their music in Windows Media Player with the headset. That's probably not going to work so well. We also really wanted to make sure that if you plugged in a pair of headphones, that we would detect that those were headphones. And maybe when you plug in your headphones, your music will play out through the headphones and not the PC speakers, because heck, you're plugging in your headphones, not your speakers. 120 million devices, 130 million devices. This is just too much of a market share. We've put drivers for Bluetooth audio in the box. So the Bluetooth audio support is in the box natively, and we support a lot of different devices. And again, I'll talk about these later on. Feature we call stream switching. Remember I was talking about plugging in your headset? Well, wouldn't it, true story, about a month ago, a developer at Microsoft named Raymond Chen, who some of you may know, he has a blog that's apparently very popular. Raymond sends me an email because he's complaining about his brand new system. He has a set of headphones, and he plugged in his headphones, and Windows didn't do anything. He plugged in his headphones, and his media player didn't understand that they were headphones and play out of his headphones. And when he finally did figure out how to get media player to use his headphones, when he pulled the headphones out of his PC, he got this great big dialog box from Windows Media Player saying, "Something horrible just happened, and I don't know what to do. Please help me." Wouldn't it be nice if Windows was smart enough to know that, hey, you know, you unplugged the headphones, let's just fix it and make the sound keep on playing? For Windows 7, we're taking advantage of that. We're putting smarts into the system so that that kind of experience just happens seamlessly. Audio latency. This is another one that has been a big issue, especially for the multimedia communications people. What we've heard from talking to them is that they have acoustic echo cancellation algorithms, AEC algorithms, that need to be able to process the sounds that are coming out of the PC and filter them out from the microphone. And what that means is that the round-trip latency, so from when you speak into your microphone, when it goes all the way over the internet to the servers of the IM developers, the IM services servers, and all the way back to the PC, in order for their applications to work correctly, they have 200 milliseconds. And if it takes longer than 200 milliseconds, their algorithms stop working right. Their experience is poor. And they asked us, they came to us and said, hey, is there anything you guys can do for us to help make it so that we spend less time in the audio stack, because that'll give our algorithms a chance to work better. And we'll be able to improve our experience for our customers if we're spending less time wasting our time in the operating system, something that they don't care about. They just want to get bits on the wire as fast as they can. Finally, the other feature I'm going to talk about in depth is a feature I call automatic attenuation of audio samples. And we call it ducking. And ducking is a term of art in the audio industry. And what it basically means is lowering the volume of audio samples so that, and then, of course, restoring them when you're done, so that you can reduce the volume of, say, background music, For example, if you're in a hospital and they have an announcement over the PA, but they also have mood music playing, when the announcement over the PA goes on, the volume of the mood music gets reduced, so you can hear the PA announcement. And then when the PA announcement is over, the volume comes back up, so you can go back to listening to the fine mood music that they've set for the hospital. And we've got a bunch of other changes, and at the very end of the talk, I will briefly go over some of the other major features that we've added in audio. But for right now, I want to concentrate on these. Before I can really dive into the Windows 7 changes, I need to talk a little bit about what we did in Windows Vista, because Windows Vista really was about laying the foundation for Windows 7. Windows Vista was really the very first major change to the audio infrastructure since Windows 98. It had actually been a really long time since we revved that infrastructure. And in Windows 98 and Windows 2000 and Windows XP, the audio infrastructure actually ran in the kernel. And it ran as a series of drivers, kmixer.sys, sysaudio.sys. Those drivers were temperamental. And we have the crash data. When we started looking at crash data for Windows XP, we were seeing that there were a lot of crashes that our customers were experiencing that were rooted inside these kernel mode drivers. So for Windows Vista, we took all of those kernel mode drivers and we moved them up into user mode. And what that's done, and again, we have the crash data to show that this is happening, it has dramatically reduced the number of Windows crashes related to audio. The other thing we did when we moved it up into user mode is we had the opportunity, and we took the opportunity to rebuild the system with a more robust, modern code base and lay the foundation for the features that we're deploying in Windows 7. The other thing we did in Windows Vista is we added this concept of per application volume. And that way, when you're playing Minesweeper and Windows Media Player at the same time, the beeps and boops that come out of Minesweeper don't interrupt your music. The user can go in there and mute Minesweeper because they don't care about the noises Minesweeper wants. They just want to listen to their music. This is an architectural diagram of the Windows Vista and Windows 7 audio infrastructure. At the very, very top in blue, you have the sort of classic audio playback APIs, the high-level playback APIs. Direct Sound with Direct Show that lives on top of Direct Sound, the multimedia extension APIs that were deployed in Windows 3.1 that all live in WinMM, Media Foundation, which is a new high-level audio streaming API that we deployed in Windows Vista that is a dramatically simpler rendering model from Direct Show, and it's got some other nice, cool features as well. Underneath all of those audio rendering APIs, we have Wasapi for the Windows Audio Session API. Wasapi has basically four major components. There's Device API, which is an enumeration API that allows you to access the audio devices on your system. Device Topology, which is an API that allows you to look at the capabilities of and the controls on all of the audio devices. Endpoint Volume, which is an API that allows you to control the master volume on your PC. And then there's the Audio Client Interface, which is the main rendering API for rendering audio in Windows. Underneath the Wasapi layer, we have the Audio Engine, which of course their job is to pump the audio samples from the application into the audio driver. And we have what we call the Policy Engine. And the Policy Engine essentially manages volume control and policies, system-wide policies around audio. There are some policies relating to terminal services and fast user switching and a bunch of other little things that are all managed by this Policy Engine. Underneath all of this is the audio driver. And the audio driver model has actually remained pretty much unchanged from Windows 98 all the way through to Windows Vista. Windows Vista added a new driver model called WaveRT, which is used by a lot of modern HD audio hardware. But in general, it hasn't changed much. One of the other major changes we had was that audio applications in Windows Vista, they refer to what are called audio endpoints. Now, in Windows XP and Windows 98 and all the versions of Windows before, when you were an audio application and you wanted to interact with the system, you actually interacted with one of these. It was an audio card. And when you told your users about where they were going to be sending their audio, you said, I'm going to render my audio to a Creative Labs Sound Blaster Live CT4870. Well, you know what? Our customers, your customers, my customers, they don't know from Creative Labs Sound Blaster Live CT4870s. That's not the way they think. Our customers, they actually think in terms of their microphone. They think in terms of the speakers that are hooked up to their PC. They think of their headsets. They don't think about cards. This just is it's a concept that's foreign to them. They want to look at and interact with their system in the way, in terms of the pieces of plastic that they see, not in terms of what happens to be living inside the PCI bus on the PC. So for Windows Vista, and of course for Windows 7, we introduced this concept of an endpoint. And the way an endpoint works is it represents a speaker, a microphone, a headset, some piece of audio hardware outside of the box and not the card. Now, to reference the endpoint concept, at the low level, we use the Device API. And here I have an example of instantiating the Device Enumerate API, which is just it's a COM object. You instantiate it with co-create instance, and it gives you the ability to enumerate all the audio devices on the machine. In this case, I'm retrieving the default audio endpoint for the computer, and I'm using the console role, which basically says, I want to access the audio device that the user thinks is the best device for just general listening to audio from music or games or whatever. The other cool thing that we've added for endpoints is this concept of an activation model. And the idea behind activation is it allows you to access a set of services that are scoped to a particular endpoint. So you can actually access the endpoint volume on a particular endpoint. Or, as I'm showing in this example, you can access the audio session manager, and that allows you to interact with the policy engine. Or other things you can use the activation model. If you're a direct sound application, you can actually activate an iDirect sound interface off of an endpoint, and you'll get back an iDirect sound or an iDirect sound capture object that is scoped to a particular audio endpoint. Similarly, for direct show, you can activate an iBase filter object, and you can use that iBase filter object to interact. Again, you can insert that into the audio render graph and use that to render to a particular audio device. The third thing that endpoints provide is a property store, which allows the user to determine things about the endpoint. Its friendly name, the manufacturer, the type of device it is. There's an icon resource inside there, a whole bunch of things that you can use to learn about the device itself. And lastly, I want to talk very briefly about audio sessions and volume control. In Windows Vista, volume control is based on the concept of an audio session. An audio session is really a collection of audio streams, and every stream in the system is associated with a single session. In general, a session is a slider in the volume mixer. So if you're running the volume mixer application, each session is one slider. Now, there's a lot of ways to mix and match sessions, and you can have sessions can be in multiple processes, and you can have multiple processes in a session. But in general, you can usually think of the system as all of the audio streams in a single process are associated with a single session. So much for Vista. Now let's start talking about some of the things we've done for 7. Device role detection. The idea behind device role detection, the first thing we did was we added a communications role. We had the console role in Windows Vista. For Windows 7, we're adding a communications role. And the idea behind the communications role is it lets a developer who's working on an IM application to know that, if the user has a headset and speakers, the headset will be the communications device. And this allows the application to know which device the user's chosen to use for communications, for multimedia, and which one they've chosen for all their other multimedia. And so they can target immediately just the communications device. The other thing we've done is we've actually added a bunch of OEM configuration information that OEMs can pre-populate on systems, and those allow the Windows audio system to make better decisions about what devices are likely to be communications. So for instance, one of the things we have the ability to learn now is where physically on a PC is a particular audio jack located. If a jack is in the front of a PC and it's labeled headphones, we now get that information, and we can feed the information that there is a headphone jack on the front into our role engine, our role determination engine, and we can then detect that, oh, you know, somebody's plugging something in there, that's a headphone. And so we're going to treat it like a headphone, and we'll stream switch and we'll move audio to the headphone, because the user probably wants to be listening to music from their headphones when they plug them in. We also know about as I said, the subtype. We know about whether the jack actually supports jack detection. Can we, in the operating system, tell if they've plugged something in or not? Again, the OEM gives us this information. We feed it into our role detection engine, and come out with an answer about which device should be the default for a particular role. And we're doing a job. We're improving and working constantly to improve the ability to just automatically figure out what's what in Windows. Reduce latency. As I said, we were taking way too much time in Windows Vista and previous operating systems. I actually went out, we wrote some test applications to measure. And this is a graph of the latency. And what we did was we basically wrote a test application that sent a pulse of audio and rendered a pulse of audio through the audio engine, through the audio hardware, out through an audio loopback cable that we looped back into the microphone. And then the signals went all the way back through the microphone and came into the application. And what I have here is a histogram of 1,500 runs through, so 1,500 pulses of audio, and I've graphed how long did it take for the audio to get from one end all the way around and back to the other end. And on Windows Vista SP1, it takes about 80 milliseconds to go from the application through the OS, through the driver, through the hardware, back out, and then back into the application. And that was a fairly high number, especially given that 200 milliseconds of time that the voice applications have. For Windows 7, we introduced a new model, a new mode that the engine can run in that we call low latency mode. And when the engine's running in low latency mode, we actually use a feature called pull mode audio that we built in Windows Vista for pro audio application developers. And we actually run the audio engine in this pull mode. And when the engine is running in pull mode, as you can see, this is the same test on the same hardware. Dramatic reduction. We had a dramatic reduction in the audio latency of the engine. The engine, and this is the shared mode audio engine, now spends about 55 milliseconds, 53 milliseconds, processing audio samples end to end through the driver. The other thing we found as we were doing this, and honestly we didn't expect this, was that the standard deviation of the round trip was significantly lower. As you can see on the top graph, there's a fairly broad spread of time. That's what the purple box at the top is. They ran from 69 milliseconds to 92 milliseconds for those round trips. In Windows 7, same 1,500 samples, the spread is actually only a 15 millisecond spread. It's dramatically better. And there may actually be some test issues in this particular test that's causing that spread to be even higher. We're much, much, much more reliable in terms of our ability to push samples through the audio engine. Stream switching. This is the feature that we added to make it so that when you plug in your headphones, things automatically redirect to the headphone device, and when you unplug your headphones, they go back to your PC desktop speakers. With a little bit of luck, your application gets stream switching for free. You don't have to change a line of code, and the system will just take advantage of it, and this will just make your application work better. But in order for that to happen, you have to use the default console or communications device. If you say, I want to render to that microphone, or to capture from that microphone, well, you know what? We're going to keep capturing from that microphone. And if the user unplugs the microphone, well, you're going to get an error. And the reason for that is because we aren't going to second guess your application. Your application said it wanted to use that microphone. Well, we don't know why. And you said that's what you're going to use, and that's what you're going to get. But if you say, I want to use the default microphone or the default speakers, and I don't care, we'll let you use, we will switch to the default, to whatever is the default, automatically for you. Now, the stream switching APIs work for the Wave APIs, for Media Foundation, Direct Sound, and Direct Show. The high-level rendering APIs that I showed in the graph at the very top in the blue box. It does not work for the WSAPI interface. So if you're an application that works directly with a low-level interface, we will not automatically support stream switching for you. And that's because it's a very low-level interface. Now, the good news is, it's actually not that hard to implement stream switching in your application if you want to. It's all you have to do, and I did this actually for a feature that I was working on in Windows 7, that it took me about a day and a half to write the feature, to add this functionality, and to write the unit test. So end to end took me about a day and a half, including testing. All you have to do is register for device change notifications, and when you see a default device change notification, tear down your existing audio graph on the current device, and then rebuild your audio graph on the new device. And it really actually is very straightforward and relatively simple, because typically you already have the code to stop the stream and to start the stream already written. As I said before, we've added support for Bluetooth in the box. We support the headset hands-free profile and the HDP high-quality audio playback profile. We've also added support for call control messages. Most Bluetooth headsets today actually support a pick up and receive button. They have volume control buttons on them. Many have keys pads and headsets. So we've actually added support to Windows 7 so that Windows 7 can actually retrieve those information and hand it to your application. And your application now can interact with the controls on these Bluetooth audio devices. Now, our call control HID messages are actually based on the low-level HID APIs that have been in Windows since Windows XP. And we've just enhanced them and taken advantage of these existing APIs and added new messages, many of which were already defined, but we're now adding support for those messages. All of the new messages are in the telephony HID usage page. And on the link up there, I have a link to the documentation for the HID APIs. They're an interesting set of APIs. They operate similar to named pipes, where you read messages from the APIs and you write using read file and write file to a stream. We provide support for the usages for dial number, dial from memory, redial, ring, call answer, et cetera, et cetera. There's about 20 of them, and there's actually should be preliminary documentation in the SDK that you all received that lets you know and gives more information about how to use these APIs. One question that I always get, however, while I'm talking about HID messages, is they say, whoa, 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 whoa. You just told me how you were getting rid of this audio card thing and using these endpoints. Endpoints are high-level constructs, but the HID API, that's plug and play. That's really low level. How do I get from an audio endpoint to a plug-and-play device? And that answer to that has to do with the property stores that I talked about earlier. We populate the PT-based device-based container ID property from the endpoint, and so on each endpoint. So you can retrieve that property, and then using that base container ID, which is a GUID, you can look up and enumerate the HID controls, the HID collections on the machine, and find the HID collection that has the same base container ID as the endpoint. You can then open the HID collection and use that to retrieve and interact with the device. Now I want to show the next feature, which is the ducking feature. And to do that, I need to go over to my PC, my laptop here. Now, what I have here on the laptop, hold on. There you are. Sorry, wrong button. So what I have on this laptop is I have Skype client, which I downloaded from the web 2 weeks ago. installed it on my machine. I have Winamp running, and I also have Windows Media Player running on this machine. Now, Skype doesn't support ducking, and in order to get support for ducking, you need to opt in. An application has to choose to interact with ducking. But we said, well, what would happen? We want to be able to show what ducking looks like and how it would work for an application. So one of the testers in our group sat down working with Skype's automation ability, wrote a test application that uses Skype's extensibility framework and enhances and gives an idea of what would happen if the Skype developers were to add ducking support to their application. So this is not Skype with ducking. We are working with the Skype developers to work on making sure that they get ducking support or add ducking support to their application, but this is just standard Skype with an extensibility application that we've added, enhanced, to show what it would look like if it was supported. So let me just use Winamp and start playing a song that is actually a song written by one of the developers or one of the program managers in my group named Steve Ball. And what happens when I make a phone call using my cell phone to the Skype account? Now, calls going out, Verizon to Skype, coming back in over the internet, and hopefully a second or so from now, it'll come in. And when I answer the phone call, all of a sudden the music gets quiet, and my phone call just comes through. And when I'm done, the music comes back. Now, that's Winamp, which is an existing application. Again, I downloaded it the other day. But we said, you know, we could do better than that. We can actually make the experience even better beyond what Winamp did. And for Windows Media Player, we've said, well, what happens if I receive a call? What happens if we would stop playing the music? So how does it work with Windows Media Player? Same song, same phone call. Out over the web, out of the internet, coming back. Latency is a problem. Come on. Phone call comes in, and this time, Media Player pauses. And when we hang up the phone call, Media Player comes right back where it was while you were playing. We stopped the music and ended while the phone call was going on, and you didn't listen a note of music. Now, when we built this feature, at the end of the milestone when we delivered this feature, we gave a demo to Bill Gates, actually. He was coming very close to when he retired from Microsoft, and he went around and was getting demos of all the Win 7 features. And we showed him a version of this demo, and Bill Gates went, wow, how did you do that? How did you get a message from Skype all the way to Windows Media Player to get Windows Media Player to stop playing? What did you do to make all that happen? And the answer is actually that it's surprisingly easy. There's really not a lot of work necessary to make this stuff happen. So let me go back to my slides. To get this working, all that we had to do was use the communications role. When a new stream is open using the communications role, it ducks all non-communication streams. So it will attenuate all of the non-communication streams in the systems. Communication streams continue to work, but non-communication streams stop. We also provide a notification mechanism, and that notification mechanism enables applications to do cool things like pausing while the music is on, while the call is going on. And because we know that users might not like this feature, we provide user and application opt-out. An application can choose not to participate in ducking. If they don't want to be ducked, and there are some reasons why, and I'll talk about them in a second, why you wouldn't want to be ducked, an application can say, you know what, ducking is not for me. So let's talk about how you actually build an application that would support ducking. And I have two applications that I wrote, and I wrote them up over a weekend, and believe me, it shows. One of them is a simple media player, and the other one is voice chat between two machines. And let's take these two applications And let's add support to ducking to them. Oops, that's it. So, here's the application. The application I'm building, the first one I want to show is a chat application. It's like the world's stupidest chat program. All it does is it uses the Wave APIs and retrieves sound samples and throws them away. But the good news is that's enough to show how ducking works. Now, oh crap, sorry, need to go back. To use ducking, the application in this case uses the Wave APIs to capture audio samples from the microphone. And we need to change the application to use the communications role. Well, if you're using the Wave API, you use the Wave Mapper just like you would in XP or Vista, and you add a new flag called Wave Map Default Communications Device. If you're using Direct Sound or Direct Show, you can activate iDirect Sound, iDirect Sound Capture, or Bass Filter off of the default capture device, the default communications device, and you will get a communications role supported stream. If you're using the Media Foundation API, you need to add the MF Dev Source Attribute Source Type OddCap Role attribute to the device graph, specifying that you want to use the communications role. So let's go back to the application, and let's add that capability. As I said, it's a Wave API, so all I need to do in this case, and I'm not Scott Guthrie, I don't trust myself to do anything more than comment out and uncomment code on stage. All I have to do is add that support to Wave Map Default Communications Device to the application. That's all I'm doing. And then let's rebuild the application. Now, let's rebuild the application. There we go. So what I have here, this is just the output directory. Because I have two applications, it's a little complicated getting to the launch in Visual Studio. So let's go back to Windows Media Player. There you are. Let's launch our program. And as I said, you can see my Uber UI skills, the remarkably highly crafted visuals associated with this application. It has two buttons, on and off. Let's start the music playing. And all I did, remember, I just added the one flag. And start and stop. It works just that easy. And it really is that easy. So that's getting ducking in an application. But you know what? That's easy. That's nice. But what about taking that same application and enhancing the media player to add support for pausing on duck? So let's go back to that media player application that I wrote, that I said I wrote. And what I'm going to do to the media player application is I'm going to add support for pausing on duck. So let's change this application. The application's a very simple application, again, with my Uber UI skills. There's a reason why I need a UI designer to help me make my visuals. Let's take this application and enhance it to pause. It's a very simple application. Again, it uses Direct Show. It renders a file. It has a progress slider, and it's got some very simple transport controls for pause, stop, continue, things like that. To do this, what we need to do is we need to register for ducking notifications with the iAudio Session Manager 2 register duck notification interface. And then we need to implement the iAudio Volume duck notification interface. So let's go back to our application. Now this is the voicemail application. And I'm just going to walk through and show what we're doing. First thing we need to do is we need support for the multimedia, the MMDev APIs, and so we'll need to add the headers for that. There are two window messages we need to support for pause and continue because this is a UI application and you want to do your processing on the UI thread. The ducking notifications come in on an asynchronous background thread, and you can't necessarily do UI on those threads, or you can't interact with UI on those threads. And here's where we have some code changes. The program itself has two buttons, auto check buttons, that enable the pause logic. And so let's just enable the window that has that. And we have an API, a function I've written called sync pause on duck. And the way the sync pause on duck function works is it says, well, is the pause on duck button enabled? And if it is, then it instantiates, using the device ABI, it instantiates an device enumerator. It retrieves the default audio endpoint. It then activates the iAudio Session Manager 2 interface. It goes out and it retrieves the current session ID. Now, the session ID is a string that uniquely identifies an instance of an application. It's just a string that says, what's my session? And this is a helper function that I wrote, and I'll show you in a second how that function works. We then say, well, is the button checked? We'll register for duck notifications. And if the button's not checked, we'll unregister. It's that easy. It's really not a lot of code to add the registration. When the notification comes in, the on-volume duck notification method on your interface is called. And when we receive the duck notification, we call post message for duck. When we receive an unduck notification, we post the unduck message. Now, in the on-session duck message handler, we go to the direct show graph. We retrieve a media control interface. If the player is running, we pause it. And for unduck, if the media player is paused, we unduck. The get current session ID, I talked about that a second ago. Again, very straightforward API. What it does is it uses that same session manager we retrieved. It retrieves what's called the audio session control interface. This, as I said, it's a policy engine interface that allows you to get and set information about an audio session, like the title of the audio session, the state, whether it's actually rendering audio or not, things like that. And one of the attributes on that is the session instance identifier. So we're just added all that functionality, and let's see what happens when we build it and run it. Excuse me. Okay, the app's now built. So let's now go down to the ducking demo. As I said, uber UI skills. Let's load the song. And as you see, we now have this pause on duck. So if we don't have the pause on duck enabled, then just like for Winamp, when you start your chat, when you start communications, it gets quiet. When you stop, it stops. But what happens if we implement pause? Now, when we start the chat, it pauses, and we start, it stops. Now, again, I show this to people, and they sit there and they say, wait, hold on. It can't really be that easy. Actually, it is. We actually went out and we enhanced, when our team, one of the other developers working on ducking, did the media player changes. The changes to Windows Media Player, a real live, for real media rendering application, production code, was about as complicated as what you see right here. Maybe a little bit more, but not a lot. In fact, it actually took us longer to write the test case for this feature than it actually took us to write the code in Media Player to get the functionality working itself. It's surprisingly easy, and I really love the fact that it is so easy to get this to work. So, now let's add support to this application for opting out of ducking, for saying, you know what, I don't like this whole ducking thing, it's not for me. Now, why might you want to opt out of ducking? Well, first off, when you're ducking, the ducking is applied over a second. There's a fade out and a fade in. And for some applications, like a media player, that can be kind of jarring, especially on unduck when the music fades back in. In addition, if you're a game, you may want to opt out so that your game audio, if you're like using Ventrilo or some other in-game voice chat, so that the voice chat doesn't interfere with your game audio. So you need to tell the system, well, hold on, wait, don't duck me. I don't want to be ducked. Duck the other guy. Duck my mail program so that I don't hear my mail program. But for me, I don't want to be ducked. The notifications and the opt-out mechanism, totally unrelated features. If you've opted out, you will still get notifications. Again, a question, it came up again and again and again as we were developing. But wait, I'm going to opt out. Am I not going to get notifications? Yes, you will still receive notifications even if you've opted out. And once again, we've tried very hard to make the opt-out functionality really easy. There's a single API you call set ducking preference. You pass it a Boolean saying, yes, I want ducking, or no, I don't want ducking. It's really, again, that simple. So let's go back to our test application, and let's add support for ducking for opt-out to that same application. So once again, I'm adding a control. I'll have the same kind of button-clicked behavior, so I need a button-clicked message handler. And now I'm going to go and enable that window. Again, I have just a sync function that's called for when you hit play to sync to make sure that the state matches the way it's supposed to be. And here's the actual sync API. Again, if the opt-out window is enabled, then just like the other example, we instantiate a device enumerator, we retrieve the default audio endpoint, we activate a session manager. It's exactly the same code you saw before. Now, we retrieve the session control just like we did when we were retrieving the session identifier. We access the session interface, session control. We retrieve a session control 2 from the session control. And then, if the button is checked, we call set ducking preference to true or false. It's really easy. It's like 30 lines of code. I love that. It's just wonderful because it's so easy to do and it's very, very straightforward. So let's see how this works and what happens when I do this. Once again, let's restart the ducking demo application. Now you can see the opt-out and pause on duck are both enabled. So now, when I go out and I load my application, now if I switch over to the chat application, it no longer ducks. My application is now immune to the ducking effects of the ducking manager. And as I said, when I'm a media player, it's actually very nice to be able to combine the two. You typically will want to actually have both pause on duck and opt out. Let me show you how that plays out. If you don't opt out, this is how it sounds. We pause immediately. But listen very carefully when I start back up. It's fading back in. And as I said, that can be kind of jarring. But if instead we just opt out of ducking while we're at it, now when I start the chat, oh, stupid. Oh. That's actually a bug in my app. Sorry about that. I didn't run into that. So now I start the chat, it stops immediately. When I stop, it picks up immediately at the same volume. It doesn't fade back in. You have a much crisper experience as a user of the application. Your customers are happier with the way they experience because it doesn't interfere with you nearly as much as it would before. So that's the ducking feature. Other features we've added, and that's really the meat of the talk about communications. So now I want to just go through very briefly talking about the other application features, the other features we've added to Windows 7. The first one is a feature that I love because it's one that a lot of customers have been asking for. And that's called what I call Capture Monitor, or what we call a Capture Monitor, also known as Listen To. And the idea here is that a lot of users have their music on a portable media player, but they don't necessarily have the music on their PCs, and they want to listen to the music on their media player. With the capture monitor feature, you can basically use an analog audio cable, plug your media player into your PC using the analog cable, and you can listen to the music on your portable media player through your PC speakers. Now, historically, some OEMs have provided this functionality in their audio driver with a hardware loopback, but fewer and fewer audio vendors are providing this functionality. As I understand it, it's largely a matter of cost. It actually costs money to add that functionality, and they would rather not. So they've been removing that functionality. But for Windows 7, we've decided to add it in as a part of the operating system so that users can now take this. And because we're doing it in the operating system, not the driver, you can actually have it work from your Bluetooth speakers, from your onboard audio playing out your Bluetooth speakers or your USB headset or any other devices on the system. Windows Vista had support for HDMI audio and has had it for a while as part of the HD audio specification. For Windows 7, we're enhancing the HDMI audio, and we're adding support for high bitrate formats. So you'll actually be able to support multi-channel audio and compressed audio formats over an HDMI connector to an audio receiver. Yeah, that's one that the media player guys have been asking for. The media center guys, the home theater enthusiasts, they've been asking for this one for a while. The next one is a feature that is near and dear to my heart because it's one of the pieces of feedback that came out of our community relations work in Windows Vista. With Windows Vista, and actually in all versions of Windows, we've never allowed the user to change the default device, the default audio output device, and that continues in Windows 7. But when we asked our customers, why do you want this? There was one answer that came back that was more common than any other answer, and it really surprised me. And the answer to that was, well, I use the Windows Media Player control to play my music. And the Windows Media Player control only goes out through the default device. So in order to get Media Player to play where I want the music to, I have to change the default device. That's silly. So for Windows 7, the Windows Media Player OCX, the WIMP control, has an API that allows you to change the default device to where you want the media player to go to, not the default device. We've also enhanced things. Thanks. Now, how many of you guys have a USB audio device that has volume and mute controls on them? Now, some of those volume controls, like on this device, are actually implemented in analog form. But on a number of devices, those are actually implemented as HID controls that interact with the operating system. Before Windows 7, those HID controls controlled the default device. So if it was like USB speakers and they were your only device in the system, that was great. But if the USB device wasn't the default, then it got really strange because you're pushing the button on your USB speakers and your desktop speakers are changing, and that's kind of weird. So for Windows 7, we've scoped the HID controls on audio devices to that device itself. They only control the device itself. One other HID control related change, and I can't think about how many times this has happened to me, and I'm sure it's happened to all of you as well. I'm in my office, I'm doing work, I'm listening to music on Media Player, and my PC, I'm not using it. I'm working on paperwork or something like that. I'm listening to music, screensaver's on, somebody comes into my office and wants to have a chat. Well, at this point, I need to stop the music. And now I got to go, oh my gosh, turn off the screensaver, hit Control-Alt-Del, log in with my password, and now finally, I can hit the mute button on the keyboard to shut up my sound. For Windows 7, if the workstation is locked, if the screensaver is active, you hit the button and the darn thing stops playing music right away. Tell me about it. That was one I really fought to get in because it was so intuitive. Why didn't it do it already? The last couple things we actually did revolve around power consumption. And Stephen actually mentioned one of these during his keynote, the reduced power consumption of direct sound and direct show. He mention it in terms of DVD playback, but we've actually done it for any application that uses direct sound or direct show to render media. If you're using any of those APIs, we will use less power in the operating system. Similarly, the multimedia class scheduler service that enables our glitch-resilient audio, the MMCSS service also dramatically uses less power in Windows 7 than it did in Windows XP and Windows Vista. And I think that's pretty much everything I wanted to cover today. So, call to action. What would we like you guys to do with your applications to help them really light up on Windows 7? First thing, all developers, please, please, please use the default or console or communications device. One of the cool things about the default communications device, the default communications device was actually defined in Windows Vista. So if your application uses the endpoint APIs to activate, you can actually activate on the default console device on Windows Vista. It will still work. Now, obviously, you won't get the new features, but that functionality will work on Vista and on Win 7 the same. Now, the new attributes, unfortunately, do not. We didn't backport those to Windows Vista. But for if you use MM Device API to activate direct show or direct sound, it should just work on Vista or Windows 7. It just gets better on 7. If you're a voice chat developer, a voice over IP, please use the default communication device. And more importantly, add support for the Bluetooth call controls. Your customers have these headsets. They're using these headsets. They want the headsets to work the exact same with your VoIP application, the same way they work with their cell phones. It's very important to them that they have the same experience. In Windows 7, we'll give you that same similar experience that you'll get with the cell phone and a Bluetooth headset, with a PC and a Bluetooth headset, as you get with a cell phone and Bluetooth headset. If you're a media player developer, listen for ducking notifications. Pause the audio streams when you get a duck notification, and obviously resume them when you unduck. If you're other developers, look at your application and make a decision about whether ducking is going to affect your application. And if it does, add the code in to opt out if you think that ducking would be inappropriate or would interfere with your experiences. It's 20 or 30 lines of code, and it's really not that hard to simply drop a block of code into your application, or it shouldn't be, to simply turn off the whole ducking experience if you want to. And with that, I would like to thank you all for coming. PDC document, other resources. As I said, there are preliminary white papers for all of these features that should be in the SDK documentation that you receive with your PDC hard drive. In addition, over time, I will be putting out articles about how to use some of these features in a little bit more depth on my blog at blogs.msdn.com, Larry Osterman. And at this point, I'd like to throw the floor open for questions. So if you guys wouldn't mind coming out to the microphones and asking questions if you have any, and I'll be more than happy to answer whatever it is you have. Thank you very much. Over there on the right?
Yes, can you opt in and out of ducking dynamically and have it do the appropriate fades while music is playing?
Can you opt in and opt?
For instance, just as a scenario, your voice chat application comes up, your music ducks automatically, but you decide you want to have something that says, hey, we've decreased your volume because some voice over IP application is active. Click here if you want to actually have your music come back.
Not from the chat application, but, and I didn't show this.
No, I don't mean in the chat application. That button would be in the media player.
Let's go back to here. I didn't show this, but.
So for pausing, yes, but.
Sorry, hold on. Yes.
For pausing, yes, but could you actually do that and uncheck the opt-out button?
Yeah. Oh, I'd actually have to look. Well, hold on. Well, okay. This will teach Larry to freestyle it. Sorry about that. The simple answer is, I think it would work the way you want it to work, but I'm not 100% certain. I'd actually have to go try it.
Start with an opt-out.
I can actually opt out dynamically. And I'm sorry, so what were you asking about? What did you want to do?
Sorry, I mean, I actually meant to start with it opted in and,
yeah.
and then check it once.
I don't actually know what happens. I think nothing. Yeah. Changing the state of the opt-out doesn't happen until the stream itself is stopped and restarted.
It would be nice if we could do that.
Fair enough. Please do me a favor, if you don't mind. After we're done doing Q&A, if you wouldn't mind coming to me in the front and asking me that same question so I can take notes and bring it back with me up to Microsoft. So, thank you. Next.
Yeah, hi. I'm more interested in the call controls that you mentioned.
Yes.
For Bluetooth. How does, when you're streaming audio, let's say I have a Bluetooth headset paired to the machine, and you pick that up as a default device for, in your example, let's say the Skype application. How does the headset know that this is a call coming in versus music that is streamed in for me to react and press the call control? Or rather, let me rephrase that question. I mean, when a call comes in and it goes to the Bluetooth headset, when I press the call accept button on the headset, how does it get relayed back to the computer?
What happens is that your IM application, Skype or whatever, is listening for the call control messages. So when you push this button, when you push the call accept button, there's a HID message that's generated. And your application, which is reading from the HID collection, will read in a message that came from the device that says call pickup or call answer or call reject. At that point, you've now read the message from the device. You can now go and choose as the Skype application to hang up the phone or accept the phone call or whatever. Does that answer?
Yeah, that helps. The second question I have is your group also responsible for speech API and?
No, the speech API is a different part of Microsoft, a part of Windows.
Okay.
Fortunately, sorry.
I have a question about the server edition of Windows 7. Are you guys considering supporting multiple audio endpoints for remote devices? Because currently for the Longhorn edition, there is a single endpoint that represents all endpoint devices, both input and output. So all streams are actually pre-mixed on the host side.
I unfortunately can't answer that question because I simply don't know the answer. Once again, after we're done, give me your contact information, and when I can actually ask the terminal server guys, because we work very closely with them, and I can ask them if they have any idea of what their plans are with respect to that. I simply do not know the answer to your question.
Okay,
I'm sorry.
you.
Yes, that's it. Well, again, thank you guys all. I really appreciate you all coming, sticking through with me at lunchtime and everything on the last day. Please don't forget to fill out your evaluation forms. And if you guys don't mind, because I've been trying to get photos of everything that I've been doing at the PDC, if you guys don't mind, would you guys smile? Smiling is a foreign concept. Anyway, thank you guys all for coming, and I really, really, really appreciate your coming to the talk.